Welcome to the deep dive. Today we're tackling a big one, actually fulfilling a listener request.
That's right.
We're unpacking one of the most significant and frankly structurally revealing accidents in aviation history.
We are talking about the crash of Japan Airlines Flight 123.
Hey everyone, if you're enjoying my videos, make sure to hit that subscribe button and ring the bell so you'll always know when I upload something new. And if you want to go the extra mile to support the channel, check out my Patreon. Your support truly means everything to me. Thanks so much for watching.
That was a Boeing 747 registration JA8119.
And it happened in Gunma Prefecture, Japan, way back on August 12th, 1985.
Yeah, a date many in aviation won't forget. Our sources for this deep dive are excerpts from the official aircraft accident investigation report.
So we're looking at the official findings here.
Exactly. And this isn't just about, the tragedy itself, though of course it was immense. It's really a deep dive into how a single specific human error years earlier.
Years, right? Not something recent.
Years in the past. How that error managed to defeat the really sophisticated, multi-redundant, fail-safe design of the world's most famous jumbo jet.
The 747. So our mission for you, the learner, is to really connect the dots. We want you to see the link between this critical structural flaw. Let's call it the ticking clock of the disaster.
Good way to put it. Connect that to the catastrophic systems failure that followed, and then the incredible, almost half-hour struggle of the flight crew trying to fly an unflyable plane.
It's quite a story. Paradoxical, as you said.
Let's unpack this.
Okay.
So JAL Flight 123, it departed Tokyo Haneda at 1812 hours. That's just after 6 p.m., heading for Osaka.
Right. And initially, everything's completely normal. Standard departure, standard climb.
For the first 12 minutes, basically. They were climbing, getting up towards 24,000 feet.
And then at almost exactly 1824.35 hours, the routine just evaporated. Gone.
12 minutes into the flight.
12 minutes in. And that moment, 1824.35, it's marked on the cockpit voice recorder, the CVR, by the sudden violent sound, a really distinct bang.
Not just turbulence or a bump.
No, nothing like that.
No.
This was clearly structural failure happening at altitude.
And the structural analysis, when you read it, it lays out this terrifying, almost instantaneous chain reaction. Yeah, instantaneous is the right word. Control loss was immediate. The investigation estimates that the vertical fin, that huge tail structure that keeps the plane stable.
The stabilizer. Yeah.
Exactly. It ruptured and actually started separating at 1824.36.18.
So just over a second after the bang?
Less than a second, really. And within another half a second, by 1824.36.22, the rudder was completely useless.
Yeah.
Gone. Because more than half of that vertical fin had just ripped away.
I have to pause there. Because losing the vertical tail, that's catastrophic physical damage we're talking about. But the operational disaster, what that triggered inside the plane, that was the real killer blow, wasn't it?
Absolutely. It's all about the hydraulics. The Boeing 747, it has 4 completely separate, redundant hydraulic systems.
Well, separate systems for redundancy.
Exactly. Hydraulics are like the blood of the airplane. They power the movement of all the flight controls, the rudder, the ailerons on the wings, the spoilers.
Everything you need to steer.
Everything.
Yeah.
And the sheer violence of that tail section rupturing and separating meant that all 4 hydraulic lines, which unfortunately run through that specific area,
Yeah.
they were severed simultaneously. All 4.
That is the impossible failure, isn't it? Because the 747 is designed, it's supposed to survive losing 1, maybe even 2 hydraulic systems.
That's the whole point of redundancy.
But losing all 4 at once, that was just outside the scope of what anyone thought was survivable.
It was a failure mode that basically rendered the aircraft completely unflyable in any conventional sense. The immediate result. The crew was suddenly flying this giant projectile with zero connection, none whatsoever, between the control column and the cockpit and the actual flight surfaces.
Just disconnected.
And totally disconnected. And just 4 minutes later, think about that, 4 minutes after the bang, at 1828.35, they transmitted that chilling phrase, "Now uncontrollable."
And the flight data recorder, the DFDR, the black box,
Yeah.
shows exactly what uncontrollable looked like, right?
Really?
The plane was just being thrown around.
Oh, violently thrown around the sky. Yeah. They experienced 2 main kinds of really scary oscillatory movements. First was severe Dutch roll.
Can you explain Dutch roll for us?
Sure. Think of it as this uncontrollable side-to-side yawing and rolling motion. Like imagine driving a huge bus on black ice and it just starts swinging its tail back and forth and rolling side to side.
Okay, got it.
The roll angles were sometimes hitting 40 degrees. 40 degrees of bank, totally uncontrolled.
That sounds absolutely sickening and impossible to correct without controls.
Impossible. And coupled with that, they had phugoid motion, Phugoid.
Hugoid motion, what's that?
That's when the aircraft constantly cycles itself between high speed but losing altitude and then low speed but gaining altitude. So the plane was basically flying itself in these massive waves through the sky.
Like a roller coaster.
Exactly. But a deadly one. Sometimes gaining and losing 4,000 feet of altitude in just one terrifying up and down cycle.
Wow. So, okay, we have this terrifying, instantaneous, systems-wide failure at 24,000 feet. But to understand why this failure was so explosive, so complete, we have to look back. Not just 12 minutes before the crash.
Much further back.
We have to look back 8 years.
That's right. That's the real core inside of this deep dive, isn't it? The fuse on this whole disaster was lit way back in June 1978.
8 years before.
8 years before. During a landing incident at Osaka International Airport, the same aircraft, JA8119, suffered a tail strike.
Meaning the very back end of the fuselage scraped the runway on landing.
Exactly. A fairly hard scrape, apparently.
And that impact, it meant they had to replace a major structural part, the aft pressure bulkhead. Now, for you listening, what exactly is the aft pressure bulkhead?
Okay, think of the fuselage, the main body of the plane, as a giant pressurized soda can to keep the pressure inside when you're at high altitude.
Right.
The bulkhead is basically the curved metal lid at the very back end of that can. It's this big semi-spherical structure, about 4.5 meters in diameter, and its whole job is just to seal the pressurized cabin area from the unpressurized tail section, the appendage where the stabilizers are, if that structure fails.
Stop. Instant decompression.
Exactly. Instant, potentially violent decompression.
So the repair itself, after the 78 tail strike, it was supposed to be a standard structural fix, right? What went wrong? What was the critical flaw they found and how that repair was actually done?
This is where it gets really crucial. This is where human error just completely defeats brilliant engineering redundancy. The repair involved replacing the lower half of this big bulkhead.
Okay.
And to do that, the engineers had to join the new metal skin panels to the existing structure using something called the L18 splice joint. Now, the Boeing designed the drawings, they specifically required 2 rows of rivets for this joint.
2 rows to handle the load.
Precisely. To handle the immense pressure load trying to push that bulkhead outwards. Especially because, for this specific repair, they had also slightly reduced what's called the edge margin. That's the distance from the rivet hole to the actual edge of the metal panel. Less margin means you need more strength elsewhere.
So double row was critical, and they
Use only a 1-row riveted connection.
Hang on, are you telling me, are we actually saying that the catastrophic failure of a 747, hundreds of lives lost? It hinged on the difference between 1 row of rivets and 2 rows of rivets on one specific structural joint.
That is exactly what the official investigation report concluded. It's stark. The structural report is absolutely definitive, this improper single-row connection. It reduced the joint to ultimate load-bearing capability by roughly 70%. 70% weaker than designed.
Yes. Now, it was structurally sound enough to pass inspections initially and to fly for years. But, and this is the key, it created this inherent weak point, a hidden vulnerability just waiting for metal fatigue to take hold over time. So this reduced integrity, this weak spot, it allowed tiny microscopic fatigue cracks to start forming and then slowly grow on the edges of those rivet holes, year after year, every single flight cycle.
Every takeoff, every climb to altitude, every pressurization cycle puts stress on that faulty joint. Little by little, crack by crack.
And they actually calculated how many cycles it took.
They did. Using electron microscope analysis of the fracture surfaces found in the wreckage, they estimated it took approximately 10,000. 10,000 flight cycles for those tiny fatigue cracks to grow long enough and deep enough to reach failure size.
10,000 flights with this ticking time bomb in the tail.
Essentially, yes. And then, on August 12, 1985, as Flight 123 climbed through 24,000 feet, the pressure difference across that bulkhead reached its maximum operational level.
Pushing outwards.
Pushing hard. And that weakened single-row connection, riddled with fatigue cracks, it just let go instantly, creating a rupture estimated to be about 2 to 3 square meters in area. A huge hole blew out.
And that's the moment the improper repair completely defeated the fail-safe design concept.
Exactly. Because when that bulkhead failed so catastrophically, all that pressurized cabin air, The stored energy of that giant soda can blew violently backwards into the unpressurized tail compartment.
Like an explosion inside the tail.
It was essentially a contained explosion, and that explosive force just ripped the vertical stabilizer structure, the fin, completely off the fuselage from the inside out, and in doing so, simultaneously severed those 4 critical hydraulic lines running through the tail cone.
Wow. The sequence is just devastatingly fast.
It is, and what's really fascinating here, sort of confirming that ticking clock idea, is the physical evidence of leakage they found during the investigation, looking at the wreckage pieces.
Leakage before the crash.
Yes. They found adhesion of tobacco, nicotine, stains basically, on the overlapping metal surfaces of that L18 splice joint, right near where the failed rivets were.
Nicotine from cigarette smoke in the cabin.
That's the theory. It strongly suggests that for a significant period, potentially years, cabin air had been slowly, microscopically leaking out from the pressurized cabin through those growing fatigue cracks into the unpressurized tail section.
So there might have been a physical sign, a telltale sign, if someone had known exactly where and how to look.
Potentially. If that leakage or the nicotine staining was somehow detectable by routine inspection, maybe during a heavy maintenance check, maybe, it might have been the key warning sign that something was wrong with that specific repair area. But it was hidden.
That's powerful. Okay, let's go back to the cockpit now. August 12th, 1824 hours. The tail is ripped off. All hydraulics are gone instantly. The flight deck transforms, right?
Yeah.
From this sophisticated, almost automated environment
Fly-by-wire, essentially.
into this desperate, completely manual laboratory. And the crew fought. They fought for 32 minutes.
32 minutes. It's almost impossible to comprehend piloting that aircraft in that state for that long. Their main tool, their only tool really, was what we call differential thrust control.
Using the engines to steer.
Exactly. Steering the massive plane using only variations in engine power.
How does that even work on a giant like a 747? It sounds incredibly difficult.
It is incredibly difficult and very imprecise. But think about maybe turning a boat that has 2 motors, one on each side.
Okay.
If you throttle up the port, the left engines, and maybe throttle down the starboard, the right engines, that unequal thrust creates a turning force, a yawing moment. It forces the nose to turn right.
So they're constantly adjusting power on the 4 engines.
Constantly. Trying to balance it. The captain was actually recorded on the CVR saying, "You'll have to control pitch with power." They were using alternating engine power, not just for direction left and right, but also trying to manage the pitch, nose up, nose down.
Which sounds incredibly imprecise, like you said, especially when you're also battling that severe Dutch roll, that side-to-side swinging.
That was the monumental trade-off. It was a horrible dilemma. Using differential thrust gave them some measure of control over the horizontal plane. Allowed them to attempt to steer back towards land, towards an airport.
Right, they were trying to get back.
They were. But every single time they adjusted the engine power for directional correction, guess what?
It made the Dutch roll worse.
Exactly. It would simultaneously excite or worsen that uncontrollable side-to-side Dutch roll motion. They were constantly fighting the aircraft with the very tools they needed to try and save it.
Just an impossible situation. What stands out to you, looking at the report, about the crew's decision-making during that half hour, particularly around standard emergency procedures?
Yeah, the investigation revealed something really critical there, a kind of paradox of human stress and intense focus. Remember the bang happened at 1824.35?
Yes.
The cabin altitude alert, the warning horn telling them they'd lost cabin pressure, suddenly started ringing almost instantly after that at 1824.37.
Okay, so they knew they had a decompression.
Immediately. Yeah. Now, standard procedure, ingrained in training, demands an immediate emergency descent down to a safe, breathable altitude, usually around 10,000 feet, maybe 13,000 feet, depending on terrain. And crucially,
Oxygen masks.
put on your oxygen masks immediately. Pilot flying, pilot monitoring, flight engineer, everyone.
But they didn't do either of those things, did they? At least not right away.
That's what's alarming. The data shows the crew continued flying for about 18 minutes, nearly 20 minutes, at altitudes above 20,000 feet, battling the control issues,
Without descending?
without initiating that emergency descent. And perhaps more concerning, the CVR analysis confirmed that none of the 3 flight crew members put on their oxygen masks. Their voices were clearly audible on the open cockpit area microphone channel throughout. If they were wearing masks, you wouldn't hear them clearly like that.
That is, wow, that's a massive operational risk, flying that high without supplemental oxygen after a decompression.
It is. Hypoxia is insidious, Post-accident testing and simulation showed that at 24,000 feet, your intelligent work capability, your judgment, your decision-making, it can degrade significantly after just 5 minutes or so due to hypoxia, lack of oxygen to the brain.
So their ability to think clearly was likely diminishing.
Very likely. The investigation concluded, essentially, that the crew was so utterly overloaded, so hyper-focused on the seemingly impossible task of just controlling the airplane, dealing with a failure mode they had absolutely zero training for.
Something no one had ever seen before.
Exactly. They were so consumed by that they bypassed the primary life-saving self-preservation procedure of descending and getting on oxygen. They prioritized trying to regain control over everything else, even as their own cognitive ability was likely deteriorating. It's tragic.
That really speaks volumes about just how novel, how completely off the charts this specific failure was. A total simultaneous loss of all major flight control.
Yeah, the report states it clearly. They were confronted with an abnormal situation which is out of the scope of the education and training they had received. It made forming a pertinent judgment about descent and oxygen incredibly difficult under that kind of extreme, unprecedented stress.
So this incredible struggle, which involved the aircraft sort of circling over inland Japan, sometimes getting close to Mount Fuji, apparently, it eventually ended near a place called Mount Mikuni. The crash happened at approximately 1856.30 hours.
Just before 7 p.m., after 32 minutes of fighting.
And the impact?
Catastrophic, as you'd expect. The aircraft was completely destroyed. The main fuselage and the right wing basically shattered into small fragments across this very steep, heavily wooded, mountainous terrain, making recovery difficult.
But despite that overwhelming destruction, almost unbelievably, there were survivors.
There were. Out of 524 people on board, passengers and crew, 4 individuals, all women actually, were found alive. All seriously injured, but alive.
4 out of 524. How? What determined their survival?
The key factor the investigation determined was their seating location in the aircraft. All 4 survivors were seated right near the back in the aft portion of the fuselage.
Near where the tail used to be.
Exactly. It seems that this rear section of the fuselage actually separated from the main airframe before the final devastating impact of the mountainside.
Broke off in the air.
That's the estimation.
Yeah.
And because it separated, it perhaps tumbled or fell differently and was subjected to less severe G-forces during that final plunge compared to the main wreckage. It created this small, incredibly unlikely, survivable pocket within the catastrophe.
Amazing.
Yeah.
And the recovery itself was challenging, wasn't it, in that terrain?
Extremely challenging. Very steep, remote area. The 4 survivors were actually discovered and rescued about 15 hours after the crash. Took time for rescue teams to locate them and get in there.
Around 11:40 a.m. the next day, August 13th.
That's right. But the subsequent investigation, analyzing everything they recovered from that mountainside, it led to some profound and really necessary changes across the entire global aviation industry.
Right. So what was the enduring legacy of JAL 123? What changed because of this?
Well, first and foremost, the structural recommendations were massive. Boeing was mandated essentially, to reevaluate the whole fail-safe design integrity concept for the aft pressure bulkhead on the entire 747 fleet.
Not just fixing the faulty repairs.
No, re-examining the fundamental design philosophy. Could it withstand more damage than previously thought possible? They even extended the scrutiny to the Boeing 767, which had a similar bulkhead design.
Okay.
And, of course, Boeing issued numerous service bulletins